Now students, let's discuss about another example between oxides and nitrides. Now let's look at what happens in the case of oxides and nitrides. For example, now as you can see on your screens that you have lithium oxide, that is your Li2O, correct? Now you can see over here you have Li2O, correct? And obviously you have, when we talk about nitride, lithium nitride, that is nothing but your Li3N, correct? Now students, how this lithium oxide is going to get dissociate? So when we dissociate this into ions, we can say that your lithium oxide will dissociate as 2Li plus O2 minus, correct? Now how will your lithium nitride is going to dissociate? It is going to dissociate as 3Li plus N3 minus. Now watch carefully, your lithium, your positive cation is common in both of them. We are talking about lithium oxide and lithium nitride. So your positive lithium, your positive charge is common in both of them. But if we look at the anion which is attached, in one case your lithium oxide you have O2 minus, and in your lithium nitride you have N3 minus. Now you can tell me which has higher charge. Obviously you can see that now that you have N3 minus as higher charge because it has 3 minus, correct? And your oxygen has 2 minus. Now you tell me in what case the highest enthalpy will be there. Easy, your lithium nitride will consist highest enthalpy or highest lattice enthalpy. Why? Because it contains simple higher charge. Your nitride contains 3 minus charge while your O contains 2 minus charge. So obviously we can say that now your lithium nitride or lithium oxide has lower lattice enthalpy than lithium nitride, correct? Now let's move ahead. Now that you have seen about the charges, let's understand what is the role of size of ion. Now that is another factor which is responsible for the lattice enthalpy, that is your size of ion. So we can say that larger is the size of the ion, weaker will be the force of attraction, correct? So if the size of ion are larger, then the force of attraction obviously will be less as compared to the size of ions when they are small. So we can say that lesser will be the lattice enthalpy in the case of if the size is larger. Okay, so we can say that your lattice energy is inversely proportional to the size, of your cation and anion. Now you can see the relationship on the screen that lattice enthalpy or lattice energy is inversely proportional to R0. Now what is R0? R0 is the total size of the molecule. So what is you mean by R0 is your size of cation and your size of anion. Simple as that. So size of the ion is another factor which is responsible for the lattice enthalpy. Now let's look at some of the example which considers your size of ion and cation and anion. Let's look at some example. Now you have on your screen lithium fluoride, sodium fluoride, potassium fluoride, rubidium fluoride and cesium fluoride. What is common in them? There are two things which are common in them. First of all contains the same negative ion, that is your fluorine, correct? All of them contains fluorine ion. But when we talk about the second thing which is common in them is the cation which is present. If you look carefully, you have lithium, then you have sodium, then you have potassium, rubidium and cesium. So you can see all are group 1 elements of your periodic table. I hope there is no confusion. Students, it is really important to remember the periodic table as most of the questions will involve the periodic table. So you have to remember, no matter what, periodic table is must. So let's come back to our example. So you have lithium, sodium, potassium, rubidium, cesium. So all of them have +1 charges, correct? And your negative ion has -1 charge. So now the charges are common in all of your molecules. Now we have to look at what? We have to look at the size of cation. If you look over here, your cesium has the highest charge, or your cesium has the highest size. Why we say that? Because as you go down in the periodic table, the size of element or atom increases, correct? So cesium, being the bottommost in the group 1, has the highest size or largest size. Similarly, then comes the rubidium, potassium, sodium, and lithium with the least size. So now, just now we have discussed that another factor which is responsible for the lattice enthalpy is size. So it is clear from this that your lithium is least in the size. So your lithium will contain or will have the highest lattice enthalpy. So if you correctly order them according to the lattice enthalpy, your lithium fluoride will be highest because your lithium has the smallest size. Then comes your sodium, so sodium fluoride. Then comes your potassium fluoride. Then comes your rubidium, and then comes your cesium. Cesium in the last because your cesium has the highest size. Now let's move ahead. I hope this question is very much clear to you. And what if the situation arises when you have size as well as charges in the contention, correct? So you have to look at that time. What you have to look is the priority. You have to give priority to the charge. You have to look at, if you have to consider the charge and size, then you have to consider that charge is the dominating factor and not size. So if the charge is more, then the lattice enthalpy will be more. So there shouldn't be any doubt. If there is any contradiction between charge and size, then you have to give priority to the charge.